Why does Cisco get the data center? Oh, yes.
Because we're already in it.
Excuse me? Say what?
We're already in it, we just don't have the box.
Yeah, exactly. Well, yeah, it really is an interesting thing, the history of Cisco and data center. And I've got scars I could show you about that. I was an IP telephony guy. I was a voice guy, phone guy, whatever they called me in my team. When we started going into what I call the data center proper, and that was in 2002, we were having a discussion, an SE team meeting. And Cisco had just announced their acquisition of Andiamo, and we were going to sell a fiber channel switch. And fiber channel is a different protocol than Ethernet and all this. And we'll talk about it. But it's spelled F-I-B-R-E versus F-I-B-E-R. So I'm sitting in an SE meeting with about 12 other SEs and my SE manager. They're talking about this in the background, and I'm not paying attention, to be honest with you. One of the SEs say, oh, I don't know anything about fiber channel and all this, that, and the other. I was in a conversation here, and I just turned around and I said, just remember this. The biggest thing about fiber channel is it's spelled F-I-B-R-E versus F-I-B-E-R. And I turned back around to talk to somebody. And just when I heard my SE manager say, oh, you know a lot about it. You're our specialist. Yeah. So don't open your mouth and use any smart tongue. That's what I learned, right? Best to keep your mouth shut. So I spent a lot of the next few months investigating what we were getting ourselves into. So I had to become our little specialist until we got PSSs and the overlays and all this, that, and the other. So I'm the one who was supposed to bring this education back to my group. So what did I do? First thing I did was figure out where I could learn about our competition. So I actually went to Denver, Colorado, right outside Denver, and took a class from McData. McData was the #1 provider of big, what they call director class, big switches, and they were great products and everything. So we'd already announced that we were doing this. McData wasn't too happy with us, so I called them up and said, I'm with Cisco, and they said, we have no classes that you can attend. We won't let you in. I went back to my boss and says, I can't go to that class. And he says, get creative. So I called him back and said, hey, I'm a consultant. I need to go in. I'm thinking about doing some consulting on this, and I don't know anything about it. Oh, we have classes open, wide open for you. So I had to strip all my Cisco gear off, and I go to the McData class. And I go there, and I learned a lot that, and I called back and talked to one of my SE friends. I was calling back, and I said, he said, well, what's all this fiber channel stuff? And I told him, I said, I feel like I've gone back to 1995. Now, this is in 2002. I said, I feel like I'm back in 1995. This is just fan out. Provides very little services, but it's just connectivity. Very, very reliable connectivity. High-speed connectivity. But there's no services in this box. And I hadn't seen our MDS at all yet. So I took a whole week class, and I'd stay late, and I saw their newest product, the 6140 that was coming out, and all that, and they had a couple of those in there, and we were looking at that, and I took it apart and put it back together and all that. So I really enjoyed that class. I left on Saturday from Denver, flew back to Raleigh, repacked my suitcase, and left on Sunday to come out here and see the MDS 9500. And when I saw the MDS 9500, I thought, man, we are going to kill this market. Little did I know. Little did I know. Fiber channel was our entryway in 2002, and we'll talk about it and everything, but it's a totally different discussion. Totally different people. We implemented a lot of new things in there. Virtualizations. We talked about VLANs. Cisco brought a technology called vSANs that nobody had ever done before. But how are you going to explain it? Well, you could say, hey, we implement vSANs. Well, what's a vSAN? What's like a VLAN? What's a VLAN? The people we were talking to were totally, they didn't know who Cisco was, a networking company or delivered lettuce out back, right? The food service delivery company. They didn't know. They really didn't. We were talking to people and they had different careabouts. Totally different careabouts. So what we did at Cisco is we started hiring a lot of people from the EMCs of the world and the other the companies have been doing that. And I got to work with them in some teams and doing some education things that we did here at Cisco. And I learned an awful lot about data center and from a business perspective. The first thing I learned of is if you take the IT budget, 60% of that was spent in the data center that Cisco had never even seen. Here's Cisco growing our company at 40, 45, 50% a year. And we were only fishing for half the fish. Over half the fish was in the data center. No wonder we did that. No wonder we went there. Yeah. So we had to get into there because that was a whole new revenue stream of something that we could get into and bring some value. We thought we could bring some value into. So let's look at how Cisco went, what the data center was, what we brought to it from that perspective, and then as we built it out. Because it was a very great timing for Cisco. Cisco entered the data center right before virtualization happened with VMware. Before it. So we actually started virtualizing the data center before VMware did, but it was just in time for us to see how these characters, and Cisco's done a very, very good job of putting products in there based on what the requirements are going to be. So let's look at a traditional how, and again, I say this tongue-in-cheek, but it's probably true, more true than not. We are they're spending all this money in data center cleaning up the mess of growing not smart for 15 years with client server. So let's just look and see how these applications might be deployed. So let me get my eraser here and erase that. So in a network, if I'm rolling out an application, applications were funded high for a requirement. So let's say you're the vice president in charge of sales of an organization, and your requirement is to grow your business 12% without hiring new employees. Well, you might might do a lot of things here, drink a lot, take a few pills, whatever it is, but you're probably going to turn to some kind of application to be more functional and efficient, right? Some kind of sales application. Now, in today's world, they might outsource that to Salesforce.com, but what if you wanted to build something internally? Well, you fund a project to actually deploy this application. You look and you find the right application that you want to deploy, and you make a decision on it. You go get a whole big chunk of money, and you own that project. So what you do is this sales application is going to have these kind of requirements. First of all, it's probably going to have some kind of database attached to it with my customers and all this. So I'm going to have storage requirements. I'm going to have some kind of storage requirements for my big database where I can back it up and do all these things. I'm going to have a SAN, a storage area network, 2 switches, SAN switches to connect to that. Create a whole network for it. I'm going to have my servers. These servers could be Windows-based, Linux-based, Unix-based, whatever it is, whatever flavor of the day is, whatever the application requires, and I'm going to have some servers. And if I have the servers, I'm going to have some server load balancing devices, at least 2 of those. And then I'm going to have some kind of firewall capability to protect this application, and then I'm going to deploy that out on my IP network and say, hey, everybody can reach this application, and I fund for that. That's how I fund for it. This has got a cost to it, and you own it. Maybe our manufacturing, we're going to be selling more widgets. We better build more widgets. We're not going to build any more new big factories. We have to do something smarter again. Again, companies turn to an application. Maybe just-in-time delivery for manufacturing, whatever it would be, and they deploy an application too. Well, again, it's a different vice president, a different tier of money, goes to the CEO, gets the money and everything, and they deploy the exact same thing. So manufacturing will get their own storage, They'll get their own SAN network, 2 switches. They'll put their servers out there. They'll get server load balancing devices. They'll get their firewall to protect it, and they'll deploy that on your IP network. Silos. Customer service. Well, if we have customer service, people with customer service who keep our customers, we might want to deploy another customer service application. And they're going to have the same thing. Storage needs, SAN, 2 switches, servers, server load balancing devices, firewalls, 2 of those, and we'll deploy that. Siloed approach for all this. Now, why did we do silos? Why did we do silos? Control. Solve a specific problem. Funded, right? Yeah.
Also because the departments are deciding on their own.
Yeah, and there may be different, you know, I might decide to go with EMC, this might be HP, and this might be, you know, somebody else, HDS, for storage, right? Again, the person whose application this is might say it works better here, better here, better here with this. Different types of servers and all this, all funded different. There were some technical issues too. Fiber channel protocol and the SAN. The SAN is in here. And we'll talk more about it in a second. But this SAN, from what we call the host bus adapters all the way through the storage, was sold as one solution. It was sold by the EMCs, the HPs, the HDSs, well, NetApp now, yeah. Back then they weren't into it yet, but they got into it quick. Smart guys. But all this, it was as a solution that was certified. And again, the SAN switches here were either Brocade or McData. Now, how much were these switches in comparison to the whole solution? This whole solution for an application rollout might cost $3 million just for that infrastructure in the back end. How much were those 2 switches? Excuse me?
10 to 15K.
Yeah. There were tax. EMC, we hired a bunch of people from EMC, and you know what they used to tell me? Those SAN switches are tax. That's what they used to say. It's no more than tax for us. We don't care. The only reason these SAN switches existed is because they didn't have enough connections on their array to be able to connect all these servers up. So they had to have fan out. In essence, Brocade and McData, how many Salesforce people did they have? Very, very few. Because what they did is they just OEM'd all of their equipment to these guys because it was in their solution. And here comes Cisco, and we're going to rock the boat. We're saying we're going to put intelligence in there. There was no intelligence in these boxes. If there was any intelligence needed, what did EMC and HP and all these guys? They wrote applications to do that. Software, because that's where their development, that's where they made the biggest part of their money. 80% of all the R&D and these people were in software. Hardware is just a way to sell it. Right? That's what it was. So Cisco comes in, and we're going to be here. But the thing about it is the fiber channel protocol is really tough. It's an unforgiving protocol. It carries a large amount of data very quickly and delivers it in order. It's a very cool protocol. But it's not like Ethernet. When you connect up into a fiber channel switch, it's a 3-step process to connect up. It's called F-loggy, P-loggy, and floggy. That's the 3 steps. You log into the fabric. If I introduce a new server into this SAN, everybody stops processing. All the servers. So all of you are servers and you're in this SAN. I'm adding me as one server. Guess what? When I connect up, you stop processing because the fabric has changed. I log into the fabric, that 3-step process, and stops all of you from processing. What happens to your application then? It just stops. So guess what? If I fund this, I'm going to make sure that nobody else hooks their servers over here. I'm going to keep it separate. That's one of the big reasons why they did this. So they'd buy smaller switches. If it was a smaller solution, they'd buy Brocade. This is what EMC would tell me. We'll buy Brocade switches for a smaller solution and McData for a bigger one. That's all it was. They didn't care. 80% of McData's business went through EMC. They had special pricing and all this. Matter of fact, Brocade had once been owned by EMC. They just spun it out saying, you know what, this is no value to us. We'll write software and sell it for a lot more. There's a bigger margin in that. Yeah. So here's what Cisco was introducing themselves into there, because we think we could change that. Everybody built this, and they had silos. People were buying storage. Think about it. I buy storage. I buy, 20 terabytes here, 10 terabytes here, 8 terabytes here of this space. Guess what? What was my utilization on the storage? Probably about 40%. Imagine going to a CFO and saying, we'd like to spend $1.5 million on more storage, but we're only using 40% of what we got. Don't tell him that. Don't tell him that. You go out, you buy a gallon of milk, you drink 2 big glasses of the milk. It's really good. Let's go buy another gallon of milk. You still got over half a gallon in your kitchen. You don't want to do that. But that's the way people did it. They kept doing this. It was inefficient. SAN switch, the ports on these SAN switches, probably less than 40% utilized. We were buying all these switch ports, but we weren't using them. And the worst thing that was happening was right here. This was the birth of the multi-core processors. All this waves, this perfect storm was happening. People were buying servers right there on this 3-year cycle. So I buy a server that's got a 2 or 4 1.6 gig processors in it, and I'm running my application. After a few years, I'm going to recycle that server. So I go, and the next time they tell me, they say, guess what? We now have multi-core processors. Well, what's that? You're going to buy the same server that's got probably 16 times the power that you did in your previous server. It's going to be about the same price. But that's what you're going to run. And you're going to run your applications on it. What happened to server utilization? Your application didn't need any more processing, but your server was giving it to you. What happened to the utilization of servers? It was going down, down, down. Matter of fact, went down to like 10 to 15% utilization because we were deploying one application on one server. That's what we were doing. So the individual application was only driving 10%, but I had to have multiple servers for redundancy and scalability. So guess what? Oh, this is terrible. This is not good. Server load balancers, again, less than 40% utilized. Firewalls, less than 40% utilized. Inefficient at best. Inefficient at best. Let's look down here. The Ethernet world. LAN switching. How come LAN switching has been utilized at least 80% by most customers over and over and over? Why? Why were we more efficient down here at using our resources than up here? One physical switch that I buy, but what could I do with it? I could virtualize it. I could use it for more than one use. I could put one application on that server, one VLAN, and if I wanted another VLAN, what did I do? I created a VLAN in it. So I could use any port, any VLAN, anywhere, anytime. So I didn't have to buy a new switch every time I wanted to have a new VLAN. We virtualized that years ago. Years ago, in the mid-90s, we virtualized switching. Virtualization started happening here. Cisco's first push, we called it consolidation of switches through virtualization. We came out with the MDS 9500 and said to customers, instead of buying all these small single unit or 1.5 rack unit high switches and everything for this, why don't we take the MDS 9500 and you buy 2 big switches and you can make any port, any SAN, anywhere. We called that vSAN technology. Our biggest challenge was not technical. It was actually getting people to understand the technology.
This is Cisco's answer to the, or rather Cisco's competitor
Yes, yes. This was the and the first customer ship was middle of December 2002. Because I actually had to start doing a training class, a 2-day training class on storage. That was fun. Had to help them build a class for that. But vSAN technology, virtualization, it consolidated the number of switches. At the same time, VMware became right popular. Now, VMware had been around for a long time. Some of us had probably seen it many years ago. People have been using it. Finally, somebody got the smarts and the guts and maybe they were drunk when they did it the first time, but they figured out that they could virtualize a server. Instead of using one application on one server, we could load software on this called a hypervisor on that server, and that's all it is. And we'll talk more about this in a few minutes. And actually run multiple applications on one server in independent form. So one physical server, I could have a Microsoft application running in there, running a Microsoft server, whatever it was. And then I could have a Linux server running in there with a separate application and another server and all that. And I could consolidate that. People were coming back with all these new processors and all this. This was great. So virtualization through VMware started helping here. That virtualization of servers. The server load balancing devices and all that. Cisco had acquired a company that did that and everything. And Cisco said, well, we need to be able to do that too. We actually had a device and still sell it today, but we're kind of moving out of that. The ACE module. Our server load balancing device goes into Catalyst 6500. It's a module that goes in there. Pretty expensive module too, by the way.
What does ACE stand for?
ACE, Application Content Engine. Huh? Yeah, we're moving to Citrix now, yes. But the ACE, we actually took the ACE and we could virtualize it and we could put 50 instances on one box. 50 independent server load balancers on one blade. So you don't have to buy all these different boxes. You can virtualize. Our firewall. Our ASA. It was the firewall service module. Today it's the ASA. The ASA can give you up to 250 virtual firewalls inside of the one box. A separate firewall instance that's got your rules for your application, another firewall instance with your rules and your application, another one for your rules and your application. So we don't have to buy a whole bunch of little firewalls. We just buy a big one. And what does this do for all this? And then finally the storage vendors started getting where they could manage all of their disks and everything. So you have virtual disk space and virtual volumes out there. That's what virtualization has done for, that's why it's the greatest thing in the world, because they've been spending 60% of their IT budget silly or stupid, depending on how you want to think about it. And the technology's finally caught up to be able to fix that. And there's been some other things that have come out of this that drove Cisco to actually do some other cool things. Does this make sense? This is what virtualization is all about. This is why it happened. Siloed approach. Now we're consolidating. The first thing we call it is the consolidation wave. Less number of devices through virtualization, vSANs, all this. But VMware, again, Cisco the only thing Cisco did was, EMC bought VMware and then spun it out. They spun VMware out as a separate company. Cisco got into the IPO. I actually got into the IPO. Not the first day like Cisco did, and I didn't invest $150 million like Cisco did, but I put a little bit of my change in there and did pretty well with it. Cisco was percentage owner. So with that investment, guess what? Then they could go in. Let's say and I can't remember the amount of money I put in, a few $1,000s. But if I walked up to VMware's headquarters and said, hi, I'm Eddie and I own 72 shares of your stock. I'd like to know all your secrets. They're going to say, turn around and don't let the door hit you where the good Lord split you. Get out of here. That's what they're going to say. Get out of here. Cisco, of course, walks up to the door and says, I invested $150 million. I'm a percentage owner. I'd like to see what's going on behind the curtain. And guess what? They showed them. So Cisco had an advantage of seeing where they were going, because they were the people who were really driving this from an applications and virtualization standpoint. So Cisco got a sneak peek, so to speak. They could tell the future a lot better that way. Yeah. So it cost them $150 million, which was not, not really significant for how much Cisco had in the bank at the time, but it was a great investment.
What percentage of the company was that?
I think they were 4 to 6 or something like that.
And do we still own that?
Yes, we do. Absolutely. Yes. Yeah. And I'm sure it grew to, money-wise, it was a great investment if nothing else. Because I think they IPO'd at $47. Something like that. 40s. So that's how virtualization has moved. And this is 2002, 2003-ish is when this was. And yeah, and this was the first wave of this. So let's just talk about how some of this can actually affect it more. And I'm going to go to this board to be fair to these people over here. Let's just talk about server virtualization for a second. And again, I like to put things in terms that relate to me. So that's why I say virtualization is the best thing since a good brownie, because I like good brownies. So let's just think about this. If I have these application servers, so I'll have a server for one application, multiple servers for one application here, multiple servers for an application here, and multiple servers for applications here. So just imagine there's more than 2 here. We'll just draw these for ease of use. The users are over here. So you have the users for the green application here, the users for the black application are on their IP network, and the users for your red application are over here. They're all on your IP network and they're sending traffic back into these servers. We got some kind of server load balancing device. On the back end of this server is the storage area network. So this is, Ethernet, access distribution core, goes into the data center. We'll have firewall, server load balancing, and all that for all these people. Back on the back side is the SAN. Now, there's special NIC cards. We have network interface cards that go this way, and these will be 1 gigabit Ethernet, and you'll have 4, 6, even 8 of those on each one of these servers. So let me put those. These are all Ethernet connections. And green. And those go on the Ethernet side, gigabit Ethernet. On the back side of this is the storage area network. So we put special NIC cards in here as well called host bus adapters, HBAs. Host bus adapters. They weren't cheap. God, too many servers. Host bus adapter cost somewhere around $1,500, $2,000 per host bus adapter. What they did is they encapsulated all the information. What we wanted to do is we wanted to fool these servers. Inside of your PCs, you have a hard drive. When a processor wants to write to that hard drive, it goes across a bus and writes to the hard drive. It owns that hard drive. Servers want to do the same thing. They're just a big PC, a heavy-duty PC. What we want to do is fool them to think that big array setting out here, this big array that's got their data on it, that's not data, Eddie. Their data out here is actually directly attached to them. That's where their database is at. So in order to do that, we have to encapsulate what we call Scuzzy protocol here and connect it up here. So these servers think they're directly attached to this. This is their hard drive. That was the magic of this. That was the magic. In the middle, we had SAN switches, fiber channel switches in here for that. For this application, we'd have the same thing. Their data would be all over here in the same big array, and they would have fiber channel switches in here, same down here, fiber channel switches over here, and their data is here. Now, what was the benefit of having all your data on this array? Why did we want to put all of our data on that big array, those big refrigerator boxes? It looks like refrigerators with hard drives in them. Security, first to consolidate all of where everything's at, right? Security. What else?
Efficiency.
Efficiency. How about resiliency? Where did EMC and all these people sell their software they sold on these big arrays? You know what it did? It actually could duplicate this somewhere else. I could have another array somewhere far, far away, kilometers away from this, build another array, put another array here, and their software actually replicated all the data that's here or there at the same time. How did EMC get all of the market share that they got very early on? It was an application they sold called SRDF, Synchronous Remote Data Facility. Now, it doesn't make a lot of sense with the name, but what it did is when this server writes to this database, they guarantee it's written to this database at the same time. That database could be a long way away. So if this ever goes down, your data's there too. Disaster recovery, business continuance. They were the first to be able to do that. Eventually everybody had it, but they were the first, and to the first person goes the best seat in the room and all the spoils. And that's what they did. That's how they grabbed market share. These HBAs would connect up to the fiber channel switches and write all this data into here. Again, Cisco's first big play was in here with our MDS 9500, where we're saying you don't need a bunch of small switches. We create SANs out of these ports. So you buy 2 big switches, and any port could be any SAN. We virtualize those. Consolidation, less devices. Less devices. So virtualization happened. People said, all right, how are we going to do this? Well, just imagine these 2 servers are running at 10 to 15% utilization. That means they've got a lot of processing power out there that there's not being used. This is where the hypervisor comes in. You load that software on here, the VMware hypervisor software, and let's say each one of these servers has, let's say they have 16, it's got 2 sockets, so we have 16 cores in there, and let's say it has 384 gigabytes of RAM. That's the server we bought. We're not using much of it. We might be using 4 cores for the black application, only 4 cores on this server running it. So I've actually got 12 cores that I'm not using on that box. Not even using. I might only be using 48 gig of RAM for that server. Well, guess what? I can separate that out. So I could actually load VMware, assign a server that we'll say has 4 cores and 48 gigabytes of RAM running any operating system we pretty much want, and put it on that box, and it's separate and running exactly what we've got now. So I've bought the software and I've done that, bought licenses to do that. Here's where the magic of virtualization happens. Let's say this application here needs only 2 cores, but maybe it needs 64 gigabytes of RAM. Guess what? I could load another license of VMware on here, run another operating system on it, so I've got 2 operating systems in separate environments, and I go out there and I take 2 cores and 64 gigabytes of RAM and create that other server on this box. What do I get to do now?
Utilize the server.
First of all, I can get rid of those. I can get rid of those servers. Now that server's running inside of these guys. That's only 2 for 1. We still got plenty of stuff up here, so let's go again. Let's run another, maybe 4 cores and 32 gigabytes of RAM for that another application. We licensed this with VMware, bang, done it. Now I can turn these off. Do you see why customers thought this was the greatest thing in the world? There were customers with thousands of servers. There's this little customer. I actually happened to know somebody who worked there and actually went in and tried to talk to them, which I didn't enjoy. You're from Arkansas, right? They're from Arkansas. Have you ever heard of Walmart? Anybody ever heard of Walmart? Yeah. Yeah, once or twice. I've seen their stores. They've got a few. Walmart. Walmart at one time had 30,000 servers in their infrastructure. 30,000 servers. Comes from a pretty reliable source that I have in there. Now just imagine, Walmart had 30,000 servers. Now they may not have all been in one place, but let's say that half of them were in one place in a data center. So that's 15,000 servers. If I do a 3-for-1 virtualization on their servers, how many servers do I get to turn off? 10,000 servers. And I have everything that I had before. Do you see why this is such a great thing? This is why virtualization is just, I mean, it's one of the greatest things that has happened in technology in decades from a business standpoint. Again, they've been sitting at 60% in there for many, many years. So they've been growing and growing and growing all these applications. How many applications does a large company have? Thousands. Yeah.
I have a question. So, say I sold them those 30,000 servers, right?
Mm-hmm. Yeah.
And I'm waiting for the refresh to come. And then the refresh, they don't need any because they can virtualize those. So where are you picking up all that?
Kind of sucks, doesn't it?
Yeah.
You get one
So
chance.
it's good for the customer.
You
right?
actually got one chance. They got one chance in the mid-2000s. They had one chance. They started selling servers that were designed for virtualization. That's what they had. They saw it coming. They couldn't stop the train. But they said, at least I get one more refresh out of this. And people are still going to refresh on a 3-year cycle.
Oh, yeah.
But it's going to be fewer numbers. So boy, it does kind of suck when you look at your future.
So what people used to do is when they encountered a situation like this, I myself was a service seller and I also used to go to accounts where I had sold servers. Mm-hmm. And when we go for the refresh, what we used to do is, one, that we used to say that these servers are virtualization ready. Two, instead of selling multiple 2-socket servers, we used to sell
a 4-socket. Yeah, a bigger one.
Scale of this.
Right. Absolutely. They'd sell you servers that were designed for virtualization. Because there's going to be some issues that pop up here that we really didn't think about was happening, which, you know, my dad used to tell me, Eddie, my dad was in the Army for a long time. He did a lot. He jumped out of planes and did a lot of crazy things. And he used to tell me, Eddie, I'd rather be lucky than good. It's what kept me alive many a time, just being lucky. Cisco was lucky here. They weren't so much good. It just happened. We didn't do anything here. We could virtualize this. That was great. But again, this is tax, not a lot of money. We had to do a lot of talking, a lot of pushing, had to get the EMC and deal with these people. Maybe we didn't want to deal with too much. But we didn't get a lot out of this. But again, there's going to be some problems pop up here. Let me show you those. But virtualization, do you understand that virtualization, why customers love it? Reduce all these things. And it's all because we got these multi-core processors and all this. That was the key to all of this. That was really the key to being able to do this. Processing power came up. I remember years ago I worked for a company, and I remember when we got the first server from Compaq that would actually have 2 processors in it. Now let me tell you how long ago it was. It was a Compaq 3000 server, and it had 2 600 megahertz processors in it. That's how long ago it was. And I thought it was the greatest thing in the world. And I ordered it, right? Oh, I'm happy. And then I put my application on it, and guess what? My application didn't know what 2 processors were and couldn't even use it. It took 3 generations of software upgrades to get it to actually realize it's got 2 processors in there. But it made me feel good for a while, right? But we got these multi-core processors in there, and that's what really opened this up. So we could drive utilization up and turn these things off. Power, rack space. People who were struggling and saying, oh my God, if I add 2 more applications to my business, I've got to get a new data center. In California, you couldn't even put a data center in California. Why? Not enough electricity. It's the truth. In this state in the summer, they have rolling blackouts. Yeah, you couldn't put a data center here. You couldn't put a data center here. Now we're saving money, reducing costs. This is really cool. This is where Cisco got lucky. I think this is where Cisco... Now, again, you have to see the luck and grab a hold of it. And that's what Cisco did. The problems started happening on this side. Think about it. These users here were going to these servers here. And these servers had 6 or 8 gigabit Ethernet connections to them. So all these users were coming down here and hitting this server down here. Now where do they go? Up here. So I might have 6 or 8 Ethernet connections or 10 Ethernet connections in here, 2 of those being network management and 8 of them being for customer data on each server. And guess what? For the people coming in with just the black application, they probably filled those up, and it was probably 40% utilization on those just with one application. And then we added the second application, the red application, so now these users don't go to these, they come up here too. And so guess what? Now we're probably at 80% utilization on this spot. Where's the bottleneck happening? Up on the connectivity on the Ethernet side. Oh, it sucks. It sucks. It sucks for everybody except Cisco. Because how do you spell Ethernet? C-I-S-C-O. What's the next step up from gigabit Ethernet? 10 gigabit Ethernet. So guess what? The server vendors started creating special servers because they saw these bottlenecks too, and they said, we're not going to try to just add more gigabit Ethernet cards in. We're actually going to put inside of our servers on the motherboard 2 10 gigabit Ethernet connections. 2 10 gigabit Ethernet connections. So instead of having 10 gig total out of this thing, now we've doubled that. We've doubled the throughput. So if you have 10 gigabit Ethernet connections here, what do you have to have on this side to catch it? Another switch that does 10 gigabit Ethernet.
Plus you got the video going.
Yeah, exactly. You got all this stuff. Yes, so that's why Cisco said, wow, so now we're going to have thousands of not just gigabit Ethernet, but we're going to have hundreds, if not thousands, close to several hundred, 10 gigabit Ethernet connections. The Catalyst 6500 was our biggest switch. Do you think it could handle it? No, it couldn't. So what did Cisco have to do? Create a better switch, a switch specifically designed for 10 gigabit connectivity. It's called Nexus. The Nexus switches. That's why Nexus even exists. The bottleneck happened here because now all these users are hitting this. And Cisco said, well, I can fix that problem. So what did Cisco do? They created a Nexus family of switches. It's 10 gigabit connectivity here. So switches that have 10 gigabit. So you put these in here, like that.
So are you saying the customers are going to spend more on Cisco and less on VMware?
No, I'm saying, listen, still, these switches, even though it's a premium, at first they were paying a premium prior, it's still not as much as that. But the benefits far outweigh any of this.
But coming back to the same point, for every dollar that a customer spends on VMware, there is an $11 attached which goes with it.
Of something else to support it,
It
yeah.
could be server, storage, anything else.
Yeah,
Including our...
Yeah.
that includes our infrastructure, yeah.
It's actually, that $11 is everything, including the software.
Yeah.
Because, for example,
It's not all Cisco.
Yeah, you came from Microsoft.
Yeah.
If there are 2 or 3 instances of virtual server, of virtual machine, that's all licensed separately.
Yeah.
So that's 3 Microsoft
Free
servers.
OSs.
Yeah.
So, and then the clouds for that.
But it's still the savings here is still amazing for a customer. It's still amazing for a customer. That $11 or 12 total largest, whatever, however you want to count it, is still saving a lot of money. Saving a lot of money. So that's 10 gigabit Ethernet. That's where 10 gigabit Ethernet. So Cisco then, we came out with the Nexus 7000, the Nexus 5000. We needed more port density, so we came out with these fabric extenders called the 2000s. So I'll talk more about that in a few minutes and all that. So we came out with a whole line of switches who were designed to do nothing but 10 gigabit Ethernet. At the same time, when Cisco got in here, we started saying, well, Ethernet is spelled CISCO. And we do know about fiber channel. But why do we even have this different network out here called fiber channel? Why do we even need that? Does anybody remember, I don't know if any of you will, some of you may, remember the old IBM SNA? SNA was an unroutable protocol. It was a big it was for all these dumb terminals and everything. It was an unroutable protocol. How did we put that on a routed network and carry it across from all these branch offices and bring it back into the mainframe from PCs and everything? We encapsulated that in IP. Cisco sold $1 billion worth of routers who did nothing but that. So Cisco had some history of being able to consolidate one protocol inside of another protocol and make it work to their advantage. Cisco's going to do the same thing here. Cisco said, why do we have all this different cabling infrastructure and everything? Why can't we do, in this box you've got fiber channel over here going out this way, and you've got Ethernet coming in this way and going out this way. Why can't we take one pipe, those 10 gigabit pipes, because fiber channel is much more expensive than Ethernet, even if it's 10 gigabit, and wrap fiber channel inside of Ethernet. We call that FCOE. Cisco came out with that. And guess what? Great idea. One cable, 2 cables in and out of this box. That's it. Simplify your cabling. 2 cables, that's it. It's doing the job of all these other things. It's the job of 12 cables before, now it's just 2. Simplify your architecture. Cisco, again, this is one of those things where there was not a standard. Cisco came up with it. And again, they were smart enough to do it because, see, they had already learned what fiber channel did. And they had the capabilities of being able to build, matter of fact, we had to build a whole new type of Ethernet. Data center Ethernet that actually would absorb this huge chunk of data that fiber channel did. Bigger frame and all this. It had to be reliable. Cisco actually created multiple standards that are standards today on this to simplify the cabling architecture. Why did we do that? Well, how do you spell Ethernet? CISCO. And it was a differentiator for us. It was, if you started in the perfect world, this is what it would look like. Cisco was new to the environment. We weren't tied to our MDS 9500. It was great that we were selling it, but we'd much rather get closer and more of the architecture with this, and we do. And it's called fiber channel over Ethernet. And now it's a standard. It's been a standard for quite a while. Data center Ethernet has, and fiber channel over Ethernet has been a standard for quite a while. It was all Cisco that did that. Why? So we could sell more Nexus switches. So we could sell more Nexus switches. This was new money into Cisco. I had it explained to me by a guy who is very, very business savvy. And he has been at Cisco a long time. And I'm going to show you what, ooh boy, that's not good. What I just saw. I'm going to try to turn this thing around here without making a mess of myself and then. I want to show you something. I hope the people on the far side of the room